So, welcome to Module 3, Lesson 15, Graphing Solutions to Linear Inequalities. Wow! Okay, well that was hard to keep up with. Anyway, trying something a little bit different because I messed up my recording. So I am now doing it over again, and I will spend another hour here. I don't even think I have an hour, but hopefully I can get this done. And yes, we are going to graph inequalities today, okay? And the graphing we'll be doing will be on number lines, okay, not necessarily our four quadrant coordinate graphs yet, but instead starting with our number lines, okay? So get ready for some good fun. Okay, and as I had mentioned, I'm doing something a little bit different this time, so it may at times get out of hand. So please give me some feedback on how you think this went. Anyway, we're going to go ahead and start with exercise 1 here, and I'm going to walk you through it as we attempt to go ahead and create an inequality, solve it, and then graph it. Okay. This first one, though, I'm going to recommend that we draw a diagram to begin with, which a diagram would be really helpful here. We don't necessarily need it to solve it, but just to show, to put this in reality and into perspective. Now, I've already recorded all of these drawings and all this, everything that I'm doing that you'll see happen on the screen, and I'm going to go ahead and try to narrate it from, well, not memory, but as it happens. Okay, of course I'm not going to be able to say everything. I had a great session, and I thought I don't know what happened. I lost this whole thing, but anyway, here we go. Exercise 1. Okay, so let me go ahead and turn this on, and let's see if I can follow what I did before. Okay, so two identical cars. Okay, here we go. That word is going to be really important. They need to fit into a small garage. The opening is 23 feet by 6 inches wide. And you can see me doing this here. Okay, 23 feet by 6 inches wide. Okay, that's going to be the size of the opening of our garage. Okay, and that could also be expressed as 23.5 feet. Okay, which is also could be expressed as 23.5 feet. Okay. All right. So that's the width of our garage. This is where our something needs to fit, and let's continue. So we need at least 3 feet 6 inches of clearance between the cars. Okay. So at least. Now I'm going to just make a little correction here because I'm going to go ahead and let's see. I'm going to stop it. Okay. So what happened here is that I was incorrect with this right here. Okay, this the first time I did it. This is kind of nice. When it said at least 3 feet 6 inches, that did not have anything to do with the sign we'll be using. Okay, because I was trying to find some shortcuts for all of us, but I did not do a great job with that. So this is actually this 23 feet 6 inches wide, it can't be any greater than that. Okay, so in truth, all that we put on the left here has to be less than or equal to 23 feet 6 inches wide. Okay, but anyway, don't worry too much about that. Let me continue with my drawing. You see how I've drawn these arrows, these three little arrows, these sections here, and let's go ahead and see what they mean. Okay. All right, and those are the 3 feet 6 inches. Okay, that we need to pay attention to. We need to have space between the cars and the wall, and the cars and the cars themselves. Okay, 3 different ways to write 3 feet 6 inches. Here's my very lame drawing of cars. Okay, just to show you that these little cars need to fit. And they are identical. I know they won't look identical at the end of this, but they are indeed identical, okay, in our problem. Okay, and we're trying to find out how wide can those cars be, okay? And that is our that is our task right now. Okay? Yes, 2C, and that's 2C, and those are 2 cars, okay? So 2 cars plus what? Plus the amount of space we need to pay attention to, and that's 10.5 feet, okay? 10.5 feet. Now here I am about to do the wrong thing again. Okay, I just paused that, and I'm going to go ahead and erase that. This is so nice. I could just erase what I did before. Okay, and means to be. Well, let's see if you can draw that line right underneath there. But so far, what we've done here is that we have taken into account the 2 cars right here, and then the 10.5 feet, which is this plus this plus this, that we need to allow for. Okay, and let's continue here. Aha, look at that, nice, huh? Okay, so yeah, all that space needs to be less than or equal to 23.5 feet, okay? Which is this right here, 23.5 feet. All that needs to be less than that. Okay, and there we go. See, I figured this out later. Oh, that's right, I did. I realized my mistake, and here all the rest of it, as you can see, taking into account all of that. So here I have my, okay, so 6.5 feet. Okay, now, here's what I was doing here. I want to just pause there for a second. What I had done is I had gone ahead, and I'm not sure where I did it, but I'm not sure why it's not showing up here, but what I was doing first was doing it arithmetically. Okay, I was doing it arithmetically. That we know, it was because we can do this. It can be, of course, all these things we do at this point are so simple that we can just do them arithmetically. We don't really need to do them algebraically. But we're making our way, and we'll see how, because algebra is just going to makes everything so much simpler and smoother. But what I had done there is I had gone ahead and, of course, I have added these all up. Okay, that extra space is 10.5 feet. Okay, the amount of space I have is 23.5 feet. So I went ahead and subtracted that away, and that left me with 13 feet. Okay, so I have 13 feet available for my 2 cars. I did the division, 13 divided by 2, and that's where I got this 6.5 feet. Okay, got 6.5 feet there. So I did it arithmetically. I kind of know my answer already, but we want to go ahead and complete this algebraically. Okay, there I am underlining the 6.5 feet there, and I think that's the end of that. Okay, so let's go ahead and see what this all looks like solved arithmetically. Algebraically. Okay, so let's go ahead and take a look and see how this looks, how we set this up algebraically as an inequality. Okay, so we had the 2C, 2 cars, plus the 10.5 feet that we need to allow for between the cars and the wall is less than or equal to 23.5. Okay, so that is the beginning of our inequality. That is our inequality written. Okay, written correctly, by the way. Okay, and as we move, we can see. I made a little bit of an error here. Just I didn't want to put that 2C there. But anyway, you see, I'm taking away the. Actually, no. Let's do this. Let me go ahead and just kind of speed this process up a little bit, because I can do that because you guys are all familiar with this already. Whee! Here we go. And boom. There we go. Okay. Yeah, and as you can see, I made my zeros with taking away the 10.5 from both sides, and then I made my 1C by multiplying by the reciprocal. Okay, and I came up with 6.5 feet. So C is less than or equal to 6.5 feet. All right? Now, so what I've done here, we're going to continue to do this throughout. We are going to write inequalities. We are going to solve the inequalities. And then we're going to graph that inequality. And that's what I'm going to do next. And so you'll see here I'm drawing my first number line ever. Okay, so here we go. Let's watch it happen in fast speed, I think. There it is. Boom! That's really quick. Can you write this quickly? I don't think you can. Anyway, here we go. Okay, so as you can see my number line, of course I need 0.5 in all of these here, so I just did everything in 0.5 increments simply because I had this as a 0.5. I don't need to necessarily. But you'll see now this is a very, very special process now in terms of how this graph needs to be drawn. Okay, and I'm going to slow it down a little bit. Let's see what I did here. I'm making some room for myself here. Get all that out of the way. Okay, I just wanted to go ahead and, just put that there very clearly. Okay, so now what I'm saying here is that I am seeing there is my point. My point is 6.5. That's where everything is going to begin because that is what is right there. Okay, that is what is right there. 6.5. Okay, my C, the size of the width of my cars has to be less than or equal to 6.5. Now that's why I put my point right there. Now that point can look a certain way, and let me go ahead and actually turn this on again because I think I do explain it. Okay, here we go. Okay, here's my explanation over there. There we go. Okay, boy, that's really fast. That's on the slowest speed too. I can draw this dot or this point two different ways. Okay, it could either be as right there as a solid point, which is what I have here. And in that case, that means that that's either going to be less than or greater or greater to, or more than, or greater than or equal to. I'm sorry, what am I doing? I'm all less than or equal to, or greater than or equal to. Okay? When you have that equal to sign, when this little line comes underneath that inequality sign, your dot is going to be filled in. Okay, dot's going to be filled in. Now you'll see later on in the lesson there will be occasions where you're just going to have either a less than or a greater than sign. Okay, in that case your point is going to be an empty circle, just a circle that is not filled in. Okay. And here we go. Now my line that I draw, and I'm actually drawing a ray. Okay, so I draw a ray. Now the ray has to move a certain way. That might be a nice little rhyme to remember. The ray has to move a certain way. And the way to determine or to see very clearly which way that ray does move is to look at your inequality sign. Okay, so your inequality sign. You can see our inequality sign right here is less than. Okay, and it is moving to the left, and it's pointing to the left very, very graciously, pointing to the left. Therefore, my line is going to the left as well. Okay, and now I can just put this arrow, this final arrow, which creates my ray because I have one ending point here. Nothing here works at all. Okay, but to the left, I have my arrow at the end of that ray. Okay, to determine. Now this right here actually can be read as this. Okay? Okay, so here we have an example, and let's go ahead and we'll do this together. I will go ahead and turn my little annotation or illustration tool on here, and I'll try to keep up with it. Okay? Okay, so it's going too fast. I'm sorry, I'm going to have to stop. Sorry. Let's go ahead and just erase all of this here. Okay. I think what I will do here is just go ahead and read it to you here. A local car dealership is trying to sell cars and that are on the lot. Currently, there are 525 cars on the lot, and the general manager estimates that they will consistently sell 50 cars per week. Now, we are going to estimate how many weeks it will take for the number of the cars on the lot to be less than 75, okay? Less than 75. We've got 525 cars on the lot. We've got 50 cars per week that the manager is estimating we're going to sell, okay? So we're trying to estimate now how many weeks it will take for the number of cars on the lot to be less than 75. Okay, and let me go see. I'm going to put this on very slow and see how I illustrated this from here. Okay, that's really slow, isn't it? Okay, so we are going to write an inequality that can be used to find the number of full weeks, which is the W, okay, that it will take for the number of cars to be less than 75. All right? Now, this W, what it's going to stand for, it's a full or complete week. So, like W equals 1 means that at the end of the week, week 1, that's what we're talking about. Okay, that's what our solution is going to be. Okay, and here's what I've written here. 525. Am I actually writing let's see what I'm doing here. I'm speeding it up a little bit. Okay, so here we go. Here's what I have for our initial inequality statement. Okay, so we have 525, which is the number of cars on the lot, minus 50W, okay, needs to be less than 75. Okay, really important here because we have the less than 75, and that's that less than symbol. It's not less than or equal to, it's just simply less than 75, okay? 525 cars in the lot, and then minus, we're taking away because we are selling 50 cars per week, okay? So minus, and then 50W, that's 50 cars per week, and W being the number of weeks. Okay, so now that we have our inequality written, let's go ahead and solve, and let's start that process here. Okay, I am taking away my 525, or adding a negative 525 to both sides. Okay, and now we can see, and at this point right here, let's notice what I have. Okay, I have negative 50W is less than negative 450. Okay, so if you remember, we talked about this last lesson. When we have this, what we're going to have to do now, okay, because we've made our zeros with, by taking away the 525 or adding a negative 525 to both sides, okay, we are going to have to now multiply by the negative reciprocal of the negative 50, okay, by the reciprocal of a negative 50, which is going to be a negative number, okay, and remember, when we multiply by negative numbers, we are reversing the inequality, okay? So what that means is that we can flip our inequality sign, okay? We can flip our inequality sign now, all right? Because we are going to be multiplying by that negative on both sides, because we're trying to get the negative 50W to be W, okay, a positive W. We are going to multiply by the negative on both sides. Therefore, we can just cut to the chase. As soon as you see you have the negative sign on both sides, okay, you can go ahead and simply flip the sign, okay. Now we have greater than, we now have 50W is greater than 450 instead of negative 50W is less than negative 450, okay, which is odd, okay, because we're talking about positive numbers here, positive integers, okay. So yeah, let me just go ahead and continue. We'll continue here and we'll just continue solving, because right now we can just simply enter our solving process, and we are doing, of course, 1 over 50. Okay, I'm going to stop right here because I made a mistake here. This was supposed to be 50 right here. Okay, 1 over 50. Okay, 1 over 50 times 450 50, and actually that was 9, okay? All right, so you see what I did here? It was, I went ahead and multiplied by 1 over 50 on both sides, got my W, and my final solution is W is greater than 9, okay? So the number of weeks is greater than 9. Okay, so now that we have written our inequality, we've solved our inequality, let's go ahead and graph our inequality. Okay, so let's go ahead and watch me draw a number line in fast motion. There we go. Okay, hold on a second. I went a little too fast there. Okay, but you can see now when I went ahead and did my graphing, you'll notice that I used the open circle. Okay, the open circle, and the open circle designates, hopefully as you're coming to understand, or actually I haven't done it yet, but I just explained it before, is that this 9 is not included. The 9 is not included. Okay, it is not included in this this solution. Okay, because W needs to be greater than 9. Okay, therefore, this right here designates that while 9 is my starting point on the graph or on the number line, it's not included in the solution. Okay, and the way I designate that is with an open circle. Okay, now I need to verify the solution. Okay, and I'm just going to show you right now in not too quick motion, but somewhat quickened motion, my verifying that 9 is not a solution, okay? And the way I do that, of course, is take my 9 and plug it into my original equation, which is 525 minus 50W is less than 75. And again, if I plug in 9, you can see I'm plugging in 9 there. You can see that that does not work because 75 is not less than 75. Okay, it's not. All right. And again, this is my original equation, which had this as a less than sign here. Okay. My final equation here ended the other way around because we needed to reverse it, but still it works the exact same way. You could always go back to your original equation here. Okay, and plug in your value, which is 9. So that's good, and that means I am justified in using the open circle as my starting point. Now, another part of this this process, of course, every problem is that we have to interpret the solution, okay, in the context of the problem. So, what exactly does this solution W is greater than 9 exactly mean? So, it means here in this case we need to sell at the current rate for more than 9 weeks. Okay, more than 9 weeks. All right, more than 9 weeks has to be. We have to sell at that current rate, which was 50 cars a week. Okay. Now what I'm starting to do here, and I'll just show you. Now we've verified that 9 is not a solution before, but now we're going to go ahead and just watch me do this in somewhat fast motion here. I'm going to use n equals number of cars, or C equals 10, okay, and see if we can actually verify the solution, because 10 is more than 9, and let's see what happens there. That's my original equation, or original inequality, okay, and you can see that that is actually true, okay, when I plugged in for, and again, here, W equals, in this case, W equals 10, okay, I plugged in, when I multiplied, of course, I multiplied 50 times 10 here to get that 500, and yeah, and then when it works out, 25 is indeed less than 75, and that is true. So I have verified my solution there. Okay, and here's exercise 2 down here, and I'm going to go ahead and read it, and I would like you guys and girls to go ahead and after that to go ahead and write your inequality, solve that inequality, put it on a graph, and interpret what it actually means, what that solution means in context of the problem, okay? So go ahead, I'll read it with you. Maybe we'll do a little highlighting of certain key points. So here we go, exercise 2. The cost of renting a car is $25 per day, okay, plus a one-time fee of $75.50 for insurance, okay? How many days can the car be rented? So how many days can this car be rented if the total cost is to be no more than $525, okay? No more than. So whatever you put together on the left side of this inequality will need to be no less than, okay, no more than 525. Therefore, we're looking at less than or equal to, okay? And again, I'll just give you that little hint. This time, I won't be giving you hints in the near future. So go ahead, write an inequality, solve and graph that inequality, and interpret the solution, and come on back. Okay, so here is our inequality written, okay, and we have 25R because that is the $25 per day charge to rent. I used R as a rental of the car. You could have used anything else, right? There's a one-time fee for the $75.50 for the insurance, and all of that together had to be less than or equal to $525 because in the problem it said it had to be no more than, okay? So no more than would mean less than or equal to, okay? Less than or equal to, all right? So I'm going to go ahead and push the button here, and we'll get a high-speed solving of this inequality, and hopefully yours looks very similar. Okay, and there we go. There you have it. As you can see, I went through my steps. Again, treating my inequality just like an equation, like we have forever. Hopefully this is becoming second nature to everyone. Getting rid of that 7550, coming up with 25R is equal to 449 over 50, and going ahead and getting my R down to 1R by multiplying by the reciprocal on both sides. And if I had not mentioned it before, I've been talking to a few of you about this. I mean, this whole operation here is when you have a unit fraction multiplied by any whole number. It's just a matter of, or any number, it's a matter of any rational number. It's a matter of just dividing that number by, of course, your denominator. And we come up with this. R is less than or equal to 17.98. Now, our question, of course, was about how many days, okay? So how many days? Now, we don't talk about days. I mean, you can talk about days in terms of a decimal portion of a day, absolutely. But when we talk about renting a car, renting a vehicle, we're going to need to talk about whole days. So we're not talking about an integer here. So what my question is to you is, would a correct answer for this question, because again, this question was how many days can the car be rented if the total cost is to be no more than $525? How many days? So would it be 17 or would it be 18? Which of those will work in this case? Okay, you think about that, come on back, and we'll do a proof. Okay, we'll do a proof, or we'll verify our answer. Okay, well, the one thing we did forget to do before we go ahead and verify our answer is I forgot to draw our graph. Okay, so let's watch that happen in fast motion. Here we go, got my graph, got my points. All right, and there's my 17.98. Okay, oopsie, sorry, let me go back. And Let's go back, 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 back. And there we go at the end here. And there's where we want to look at. Okay, yeah, so we had our inequality less than or equal to 1798. Again, you can see this, our dot, our point is filled in because of the and equal to or equal to sign that is right there. Okay, it's moving to the left, of course, because we're going less than, and our sign tells us to do just that. Okay. Okay, and in terms of verifying this answer and deciding which of these over here is would be our correct choice, 17 or 18, I think some of you will know that already because R needed to be less than or equal to 1798, and that would hint to the fact that 17 would be the correct answer. And you'd be correct. But let me just go ahead and show you this verification process. And again, this is something we've done quite a bit. So if I take 25, and of course I substitute my 18 in there, we're just checking 18 first. Okay, 18 plus 7550 less than or equal to 525. Okay, and then I have got to do my multiplication here. Let me pause and do some multiplication. Okay, so back here I got 450. So it's 25 times 18 is 450. And if I add that plus 7550, I get 525.50. And that is supposed to be, if it were a solution, less than or equal to 525. And it is not. That does not work. Falso. Okay, it does not work. All right, so we know 18 doesn't work. Common sense would tell us that if we were to subtract 25 off of this, that would equal what? $500.50, and that would be correct. So yeah, 17 is verifiable solution. 18 is verifiable not solution. Okay. Okay, so here are some more, some additional exercises. Give us some good opportunity to practice. Alrighty, so as you can see, for each of these problems, I would like you guys to go ahead and, here we come, it's coming, I'm waiting for my annotation here, because there was a game actually that was meant to be played in class, but that game won't work so well for us. So we are instead going to write, solve, and graph the inequality and interpret the solution within the context of the problem. Okay? So that's right. So for each one of these to come up, I want you guys to go ahead and write, solve, graph the inequality, and then interpret the solution. Okay? And that means, how does that make sense? What does it actually mean? What does that solution actually mean in the problem? Okay? So for this first one, Mrs. Smith decides to buy 3 sweaters. Okay, 3, keyword here, 3 sweaters and a pair of jeans. She has $120 in her wallet. If the price of the jeans is $35, what is the highest possible price of a sweater? Okay, if each sweater is the same price, which makes a big difference. Okay, it's not always the case, but let's say she's going to buy a similar sweater in 3 different colors. Okay, so use all that information. Go ahead, and this is your time to shine. If you would, go ahead and write your equation, solve that equation, graph that inequality, and then write an interpretation of that solution. Okay, and then come on back and we'll check it together. Alrighty, so here is the inequality written out, 3s, okay, which is the 3 sweaters, plus 35, which is the price already paid for jeans, okay, and then has to be less than or equal to 120. I chose that because that's all she has in her wallet. She could afford 120 because she has that in her wallet, but she can't go anywhere over. So it's got to either be less than all of that. The price of the total for the sweaters and the jeans have got to equal something that is less than or equal to 120. Okay, so let's go ahead and I'm going to hit the button here. We're going to watch this be solved, and hopefully you did a super duper job. Speed it up a little bit. Get through this thing. Wanted to get it before I started my graph. But anyway, there it is. S, that means the possible sweater. Okay, that's a price of the sweater in this case, because that's what S is standing for. What is the highest possible price of a sweater? Okay, is $28.33. Okay, so she cannot spend more than $28.33 for each sweater, but she can indeed spend $28.33 because we have our or equal to sign underneath our less than sign. Okay, so let's maybe slow this down a little bit. Let's go ahead and watch the graph being drawn. Our number line, and there we go, finding some spots again. This is all pretty much arbitrary as long as you have the key data points, the points, and of course 28 is a real important one. Now you can see where that has gone, a little bit more. Okay, so that is the point 28.33 or $28.33 is just to the right there of $28, and it is filled in, of course, because we have our the point there is filled in because we know we are looking for less than or equal to. Moves to the left because that's the way our inequality sign is moving to the left, which means less than. And in terms of an interpretation of this solution here, S is less than or equal to 2833, looks like the highest price she can afford to pay for each sweater is $28.33, and I'm not sure what all that was about. Okay. Anyway, yeah, I just did a bunch of, so we have, what I was trying to say at the end there is we have written, we have solved, we have graphed, and we have interpreted, okay, those 4 steps. I want you to go ahead and take on question 4, or exercise 4 here, right down there. Take it on for yourself. I'm sorry for coughing like that. I'm not even going to read it to you. You go ahead and do it. Come on back and we will check it out. Okay, welcome back. I hope you've achieved some success. I want to go ahead and read. I'm going to turn to a clean sheet of quote-unquote paper here, but I have to read the question because the question is down here in the bottom. So it says, members of the select chorus agree to buy at least 250 tickets for an outside concert, okay? They buy 80 less lawn tickets than balcony tickets. You know, we've worked a couple of these problems in the past, and they've been in some problem sets. We've done things like this in class. They're tricky, it looks like, but I'm so excited for most of you because you will no longer be tricked by these problems, okay? So they buy 80 less lawn seats tickets than balcony tickets. What we are trying to figure out is what is the least number of balcony tickets bought, okay? What is the least number of balcony tickets bought, okay? So let's go ahead and see what this looks like as a inequality. Okay, so here our inequality is being written. And so we have B plus B minus 20. I'll have to speed this thing up. Okay, so B plus B minus 20. Now these are actually two separate things. If you ever wanted to, these are 2 separate numbers. This actually is B plus, and then B minus 20 is another number, because remember we had 20 less 20 less lawn tickets than balcony tickets, right? Okay, so this is the balcony tickets, and here are the lawn tickets, okay? So B plus B minus 20 is greater than or equal to 250, okay? I don't want to do that step quite yet, though. Yeah, so here we go. So greater than or equal to, okay? Because it says they're going to buy at least 250, okay? At least. So they can be 250, but it'd have to be at least 250. It could be 250 or it could be more. Okay, could be more as well. All right, so let's go ahead and watch it get solved. 2b, what did I do right there? I know a lot of you really do this really well. We combined like terms, right? Two B's came from our B here and our B here. Okay, two B's. We're not distributing anything here. The reason I put it in parentheses, and hopefully it's not confusing anyone, because I don't mean to confuse you, but I just wanted to show you that those are two separate entities. You know, the one inside the parentheses was the lawn, and the other one was the balcony. But anyway, so we combined like terms, the two B's, and then we continued from there, and I'm just going to let it go and stop talking while it solves itself. Look at it solve itself. And you notice what I did there. I was subtracting the 20 when I should have been adding it initially. Because here we're trying to get rid of this 20. Maybe some of you actually made this mistake, or initial mistake like I did. We are not subtracting that 20. We are actually adding its inverse, right? Adding its additive inverse. So that means we're going to add to this side as well. And that becomes 270. We go ahead and multiply by the reciprocal of the 2b. And we end up with b is greater than or equal to 135, okay, 135. So that is our solution there, okay? Let's go ahead and next let's watch the graph be drawn. Here it is. Let's maybe slow that down a little bit. Okay, again, just finding my places along the, again, somewhat arbitrary, but yeah, you didn't have to make this. You don't have to make this many points on the number line, but I don't know. I guess I like number lines. And there we go. Dot is filled in. The point is filled in. Question to you is why? Why is that point filled in? And hopefully you've come to know that it's because we are talking about greater than or equal to. Which way does our ray point? It points to the left, because talking about greater than, and handy dandy, our inequality symbol is pointing our way to the right as well. Okay, let's interpret our solution. And the least, I'll go a little faster here, speed this up a little bit. The least number of balcony tickets bought is 135. Okay, 135. Okay, so it has to be more than or equal to 135. Our question asked us what was the least number of tickets that could be bought, and that would have to be 135, okay, because 135 or more, and 135 is the lowest number, and you can see that it is the first number in our solution set, okay, and we'll be writing solution sets in the near future as well, okay, but yes, it would be 135. Okay, well, I hope you did well on that number 4. Here's number 5, okay, and number 5 is pretty straightforward. No flipping of arrow and no negative this and that or the other thing. So, would you go ahead and do it? And again, remember, you are going to write the inequality, solve the inequality, graph the inequality, and then interpret your solution, okay? So go ahead and do that, and come on back. Okay, so here we go. We have Samuel, and Samuel needs $29 to download some songs, okay? Needs $29, all right? His mother agrees to pay him $6 an hour for raking leaves, and in addition to his $5 weekly allowance, okay? Our question is, what is the minimum number of hours that Samuel must work in 1 week, okay? That's really important, 1 week, to have enough money to purchase the songs and movies, okay? So we got $29 for the songs in total. He's going to get $6 an hour for raking leaves, and he's going to get the $5 weekly allowance, okay? So if you went ahead and did it, let's watch the, um, inequality grow. Go 6h plus 5 greater than or equal to 29. Okay, let me just stop it right there. And you can see 6h is the $6 per hour. We are solving for hours, therefore we have our h here. Okay, 6h plus 5, which is that $5 weekly allowance, has to be greater than or equal to 29. Okay, he needs $29 to load some songs, so he has to earn at least $29. So he can earn $29, which would be fine, which is why we have the and or equal sign too. But it has to be either more or less than. Okay. So let me go ahead and hit the button here, and we'll go ahead and watch this solution grow. Put a little speed on it. Oops, sorry. Oh gosh, that was so quick that my graph started to grow as well. Let's see one more. Okay, so there we go. So now we have our H, or hours, is the number of hours he has to work per week is more than or greater than or equal to 4 hours, okay, in 1 week. All right, so here we go. Let's go ahead and watch the graph grow. Told you this was pretty straightforward, really simple, no decimals, nothing funny, and there it is right there. So this graph, like all of our other graphs or number lines that we create here, this is just a graphical depiction, okay? If you guys have ever heard that term before, a graphical depiction of that, okay? So that solution right there is graphically depicted or shown by this right here. So I could, if I showed you that just by itself, you could write this inequality for me from it, okay? So now in terms of our interpretation, here comes Sammy boy needs to rake leaves at least for, oh, I put days, but I meant hours. Watch me change it. More, for, oh, come on, Frank. For, find your mistake. There we go, hours, okay? Yes, Sammy boy needs to rake leaves at least 4 hours to earn the $29, okay? And hopefully you all got that. Okay, and here's my closing slide. And again, this was done very differently because of my little technical failure earlier in the day. It is now later in the day. Hopefully some of you can get on here and do this today, which is Thursday, January 8th, 2015. But I'm going to go ahead and run this. I want you to just give me some feedback, if you wouldn't mind, after you do watch this and work along with it, if it worked at all, because this might be a total mess. I don't want to actually go back and look at it before I post it, because that'll take me way too long, and I'll probably end up doing it over again. So do give me feedback. I'd really appreciate it. But here we go. This is my closing slide. I'm going to slow it down a little bit. I'm not sure what I said exactly, but yes, okay. What I was trying to talk about here is that if I drew this graph, okay, and it's just what I said before, but in closing, let's speed this up a little bit, get these numbers done. And done. Okay, so drawing this graph and then completing it, boom, right there, I should count on you to be able to create going from this graphical depiction to a numerical depiction of this graph, which would look like that. Okay, would look like that. N, in this case we'll use N, is greater than or equal to 135. Okay, 135. And again, we know it's going to the right because we can go to the right or the left, but that ray, this is showing that we are moving infinitely to the right. Okay, we're not moving to the left because, and we know that 135 is included because of our filled in circle. Okay, alrighty. Now, yes. Okay, this is a bit confusing right here, probably. This little part I wrote right here. What I meant by by this part here is if we had if that circle up there was actually not filled in, 135 would not be included. But That's what I was making. That's the point I was trying to make, but that moved too quickly for me to fill that in with any words. But it's not. It's not an empty circle. It's a filled-in circle. Therefore, 135 is included in the solution. Okay? Direction of arrow, you know which way it goes because you can see it right there. Okay, you can see it right here. Okay, it's showing you which way it goes. Greater than, of course, always moving to the right. Less than, always moving to the left. But if in doubt, just look right there for your inequality symbol. Okay, well, I had a lot of fun doing this. I hope this works for you. Again, give me a call, send me an email if anything is confusing, and please do leave me feedback on this one because for all I know, this could be an absolute mess. Okay? See you soon.